Hello and welcome to the modular Melody Maker build log 4. So I mentioned at the end of the third build log that I was going to get 4 in, 4 out working. And as you just heard, I did that. It was very simple in software, basically just duplicating the code that I had already done for the 2-channel. Now it's 4-channel. And what's exciting about that is, as you just heard, I was sending one note of a chord to 4 different oscillators and then triggering it with a random waveform. For simplicity, it was the same trigger on each ADC channel. I was just using a splitter that's off to the side just to keep the cabling a little simpler from the Eurorack, which is over there. So from that aspect, you weren't getting as much variation as in the end I would like to hear, but it was working. And the music theory nerd in me thinks that it would be cool to then experiment with almost kind of chorale style chord sequences and get the shifting going, and you could get some really cool things, I think. So that would kind of be the end goal with that. But the other thing I mentioned at the end of the third build log was taking in, starting to add in the gate in circuitry. And doing gate in to sequence patterns similar to the MIDI Melody Maker project that I referenced at the beginning of this whole process, which will be kind of the other core functionality of this build. The quantizer is just kind of one option, and then the other option is having these kind of set sequences that you can bring in. But I'm actually gonna shift a little bit because to give you some timeline perspective, the second and third build log were filmed kind of 2 days apart and about 2 weeks ago. And so now I've basically kind of been playing with that functionality that I brought in. And I've made some notes and had some thoughts. And one thing that I think is going to cause problems if I continue just doing focusing on software is that this breadboard setup, although better than the first initial wiring where there was a lot of stuff going on, a lot of interference, I still notice that if I, hit certain wires or touch certain things, the output from the DAC or the input from the ADC is affected. And that is not ideal because then I can't really tell if it's, when I'm prototyping, is it the software that's causing these problems or is it the hardware? So I think I'm actually going to kind of step back from software for a little bit and do some hardware. And I am going to make some breakout PCBs, and I've made some notes. Even though I do a lot of stuff with technology, obviously, I still, I like to handwrite my notes. Basically, I'm going to do PCBs. There's going to be 4 PCBs. One's going to be for the ADC inputs, the 4 mono jacks, and then a breakout spot for the stemma board to plug in. And then the DAC, same thing, 4 mono jacks, spot for the breakout PCB to go in. And then the gate in as well. And that's 4 gate in circuits. The only question I have on that, I haven't quite decided yet, maybe I'll do one of each of these, is I have this breakout board that I kind of soldered up. It's based on Thea Flower's excellent resource, Building the Big Honking Button. And so I referenced her schematic and built that from there, and I will link that down in the description. So the question is, do I do a single breakout and, build 4 of them, or do I actually make a breakout board that has 4 gate ins? I haven't totally decided that yet. And then I was kind of doodling kind of the layout, because initially, I'm thinking you'd have your 4 at the front, and then your board here. But that leaves a lot of kind of dead space. And at first I was like, oh, maybe I could do a kind of a cutout, almost like a T shape. But then I remembered, fab houses, you pay for the dimensions of the widest and tallest point. So it's still a lot of dead space. So then I kind of thought I could do a board in the middle and 2 jacks on each side. And then that's kind of, it's using the space most efficiently. And then, for prototyping, I don't necessarily have to have it oriented perfectly for performance. Because performance, ideally you'd want all the jacks in line and everything like that. But for prototyping and also to keep costs down on the PCB, keep them as kind of small as possible, I can do that layout, and I think that'll work well. So the next thing is going to be designing up these PCBs. and they should be fairly simple. And I think that will make it a little bit easier on the prototyping end. But first, before I do that, I just want to share, because I've had this notebook for a while. And it was my first notebook I used when I was getting started with Arduino electronics. And I found it when I was going through my desk recently. And you can see these are kind of my original notes, and it was June 14th, 2011. The reason why it's dated is at the time I was in college, and I'd been talking about this kind of stuff with my advisor, and we discussed maybe doing an independent study course to work on this stuff, but with like a music tech perspective. And so that's why I was taking really copious notes. I was dating things to try to bring that together. I ended up not doing that because it would have been a terrible idea, because, reality sets in. I was working 3 jobs, and I was double majoring, and I had a minor. So to then like design an independent study that I had like no real faculty help with would have been such a disaster. But I'm glad that I still have these. And so this was like going to be a Reason controller, and this was the layout. And I did get like a breadboard kind of style prototyping, which is basically, if you've used Reason, it's like this kind of visual interface thing. And so basically I wanted to take that visual interface with the mixer and make it hardware. And I was able to map the pots to the different things. So maybe that's something I'll revisit at some point. And here's, how to wire up a MIDI jack, and the layout for an LED and a pot, and abstract code idea. Each position on a switch have a set of MIDI commands. There's one. I don't know, it's fun to look back at it. I'm glad I have it. And I was trying to understand how code works there. So now to further use this notebook for larger concepts, I think it's a fun evolution, because I normally use these little field book things. And I do have notes in here as well for the modular melody maker. And you can see here I've got notes on, how the graphics are going to be, and which is going to be another thing I'll be working on shortly. And then also some notes on, while I've been using it for the past 2 weeks, functionality I've noticed that I'm going to want. For example, I think I'm going to want a reset switch to clear out the notes. Because the hardest thing I think with modular synths is doing transitions. Because it's really hard to have it be subtle and smooth and not feel like you're just going like, okay, and now we're going to this. Like, it's tricky. So I think, there's going to be some sort of switch, maybe an additional step switch off to the side that clears out the notes. But I was also thinking like that's also very abrupt. But I think for testing, it will be handy to have that. So at least that. But then maybe there's like some short press, long press functionality with that switch, where maybe it's like short press, it clears it. But then long press, if you hold it down, maybe it'll keep playing the notes that are already programmed in. But then it'll clear them, and then you can put in what you want to do next. And when you release, it transitions. I think that could be fun. And that only comes from playing with it and getting an idea. Because I could probably marathon this project and like get all the code in and like just get it going. But there is something to be said about letting it kind of marinate for a bit and not rush with it. And especially something that's large scale that I want to be using daily. I want to make sure I really consider, all the options, and a lot of the stuff, it's not going to come up in the initial brainstorming. It's going to come up over time. Like, hey, this would actually be really handy. And implementing all the code stuff isn't completely necessary at first, because once the hardware's set, I can update the code whenever. So it's really just making sure, like, I think through what features I want to have in there. And then I could even go to final hardware design, but still be working on the code. So I think right now I'm going to be kind of stepping back from the code and doing some hardware stuff. So this build log's all about breakout PCBs. So I'm going to go settle in on my couch, watch some TV, design some PCBs, because it is the awkward week between Christmas and New Year's, where what even is. So I'll do that, and then I'll bring it back in to see what I came up with. Okay, so I ended up designing 3 breakout boards. One for the ADC with 4 mono jacks, one for the DAC with 4 mono jacks, and then a gate in breakout. So let's take a look at those. So this is a schematic for the ADC, and when we look at the DAC one, you'll see it's basically the same, because once I did the ADC, I just saved it as a new and then update it for the DAC. And I could make this a little fancier with like a nice layout thing, and I probably will before I throw it up on GitHub. But yeah, so basically, 6 header pins on each side to plug into the ADC stemma board. And then the jacks, these are the thonk jacks that stand up and just go into ground and signal. So then if we go to the board layout, so these are all the layers, including the back silk. In fact, let me turn off the back silk. All right, so here's the board layout. As you can see, the 4 jacks, input 0, 1, 2, 3, the stemma board. The stemma board's oriented this way because when I was sketching it in the notebook, I thought of like, that way the stemma cables can kind of go off to the side, like up and down here. And then that way, the I2C isn't touching any of the jacks, and it's kind of separating them out a little bit. So I think that'll be good. And then we've got mounting holes as well. One thing I did that was new though for these boards, and let me bring back in the back silk for this. Phil B, who I work with at Adafruit, he does a lot of really amazing, cool stuff. But one thing he did recently was this tool called Penguin, which is a tool to bring in custom fonts for Eagle. So basically you can have these font objects that you just do with the normal text thing in Eagle, and then you can run this script and it creates this kind of copy of your board file, and you open that up and your text has been transformed to whatever font you define it as. So I think if I bring up my Ubuntu window, yeah. So basically like you are in your folder and then you run it and you direct it to the location of your board file. And then there's like 3 font types in Eagle, vector font, I forget the other 2, but begins with a P, and then there's another. But either way, basically you set a font that all the vector fonts will be transformed into, and a font that all the P fonts are turned into. And so for this example here, all my vector fonts I used for like the description, they're vector fonts, but then I used a different font for these emojis. So then I was able to bring in an emoji font to have emojis on the back as like really low effort PCB art on the silk. And then this Blitzay DIY bitmap is one I made a while ago. I brought that in kind of the traditional way to bring in bitmaps to Eagle. So this is the board for the ADC. And then I also did a DAC breakout where here's the DAC, and same thing, did the penguin layers there. I did stop around the holes so that there's no silk. You kind of get just the substrate there around the hole. I like that look. So basically the DAC board's almost like a copy of the ADC board as far as layout goes. And then, obviously routing's different because of where the pins are located, but again, it's just like the jacks going to the output pins on the breakout and then ground. And that's basically it. And again, this layout so that the stemma cables can kind of go off the middle here. And then the final breakout I did, as I said, like I was kind of going back and forth, like, do I do a 4 gate in layout or do I do a single? And I decided on a single layout. And the reason why is this way, I feel like the board's a little bit more handy, not just for this project, but in the future, like to just have a single little small breakout that can do that, I think is good. And then also, might be handy for other folks too, when I release the files, you can just make you have a quick, easy gate into 3-volt logic board. So not bad. And this is, again, based on Thea Flowers' article on designing the big honking button. She has a section on the gate in, which is the circuit. And I used that when I built my little breakout board version on perf board, and then referenced it again when I was doing this breakout board. So again, big thanks to Thea. Her resources definitely have made this project possible on a lot of levels. So for this board, it's very small. And then again, I did the penguin tech stuff. No emojis on this one, but just, on the back, Eurorack gate in circuit. And I like to date my boards and also the version number, just as like a reference. So that's there. And not only did I do just a single one because I thought it'd be helpful, but also for cost, because, you can't just order one board. You have to order multiple ones. I'm using Oshpark for this order. I tend to use Oshpark. I think I've only done another Fab House once, and it was only because I really wanted red silk. It was for like a Christmas bauble, like kind of nonsense PCB. And Oshpark, it's a minimum of 3 per board. So my other thought was like, it's going to be kind of a waste to have all these gate in boards when I could just have, I could just order, it'll be 6, but it'll actually be cheaper and more efficient to do that than to order 3 of the 4 in. So that's why I did that. On the flip side, I'm going to have 3 of the DAC and the ADC boards. I might see if anyone wants those. Time will tell. But I have sent them off to Fab. This is the back of the board in Oshpark's viewer. And there's the ADC front. There's the gate in front. There's the DAC front. There's the gate in back. And these lines here from the vector import of the penguin text, those aren't visible when the boards come back from Fab. I know this because recently Lamore has switched the boards over to using the penguin font. I've seen them in person. They're really sharp. They're really nice. So that was another reason why I kind of wanted to try it. And this is the font I tend to use on my video thumbnails. And I just like it because it looks kind of like, retro gaming kind of stuff. So yeah, those are the boards. So I didn't do super rush thing, but when they come in, I'll solder them up, test them out. I'm hopeful that they're going to be good, but time will always tell. And the reason why I also did the mounting holes for this is so then I'll be able to put like some standoffs on the bottom to keep them off the ground or off my desk, so they'll be nice and isolated. So I think it'll be really good for the further prototyping of this. And I gotta say, like, it was probably my easiest time I've ever had with Eagle doing the schematic and then bringing it into the board layout, because I use Eagle a lot now for my day job work with Adafruit, where I do some of the new product guides. I have to go into Eagle to get the schematic printout and the board layout, and also often I'm looking at the schematic to, write up the pinout page to say what each pin is doing and what they're connected to and stuff like that. So I definitely felt more comfortable in Eagle than I had previously. So I'm excited about these. I've never ordered 3 at once. It's usually just like 1 I'm working on. So yeah, but I do have a rule for myself that I don't let myself order a PCB the night that I finish designing it, because I did the DAC and the ADC boards in the afternoon yesterday, and then I did the gate in at night, and it was very, very, very tempting to hit place order, but I resisted, and then I did it this morning. So there we are. But I think that's going to do it for this video. I'll have the board files and everything up on GitHub in the Modular Melody Maker repository if you're curious about them. Just know that unless there's a note on GitHub saying they've been tested, they have not. So if you do anything with them or order them, I can't guarantee that they will work. I don't know for sure yet. But that's going to do it for this video. Thank you for watching. And next time, there will hopefully be some soldering happening with these boards.